Okay, good morning. Welcome to
KidMath157.
KidMath157. So we started a new section in our algebra book today. It was about the functions floor and ceiling, and this one is called ceiling. What was floor? What does floor of a number mean?
It means round down to the nearest integer below it.
Okay, so for example, floor of, I don't know, 3.14 is equal to what?
3.
3. And how about ceiling, which is written the other way? Ceiling of 3.14. What does this mean?
4.
What does it mean?
It means round up to the nearest
Round
integer.
up to the nearest integer. And the only time it gets tricky, is there an eraser behind you at all? The only time it gets tricky is a little bit on the negative numbers. Like what is floor of minus 3.14?
It's minus 4.
Minus 4 because you round down. Now how about ceiling of minus 3.14?
It's minus 3.
Minus 3. Because minus 3 is bigger than minus 3.14.
Yeah.
Right? So for this, during our time we were talking today, we graphed floor. So we're going to, for the movie, we're going to graph ceiling. Any way you want?
Well, 0, 0 is on it. 1, 1 is 2.
1, 1 is 2. Okay.
So 2, 2.
All right.
Those are all on it.
Yep.
Same for minus 1, and minus 2, minus 2.
Okay, so integers, when we round up or round down to the nearest integer,
It doesn't matter.
stay the same. Okay, good.
Well,
May as well fill in 0 as well, just to make it complete.
let's check at a half.
Okay, at a half. What happens at a half?
At a half, it goes up to 1.
All right.
So it seems like there's this line. It all goes up to 1 for any point here.
Okay, any point where? Let's, instead of just pointing, what points
Between
go to 1?
0 and 1.
Between 0 and 1. Okay, go to 1.
But not at 0 itself. So
Not at
we
0.
can make an open dot there.
Okay, very good.
Then the same is going to be true for 2. All the numbers between 1 and 2, not including 1.
Okay.
And then all numbers between 0 and minus 1 will go to 0.
Ah, see, this is right. This is where we got to be careful. Okay, so what is that part going to look like?
So it's going to be this with the open hole and 0. Oh wait, no. Yeah, 0, actually 0 stays 0. The open hole's on minus 1.
The open hole's on minus 1. So 0 doesn't have a filled in and an open. It has a,
You can use big dot.
yeah, big dot theory. Okay, good.
Then from minus 1 to 2, not including 2.
Minus 2.
Yeah, minus 1 to minus 2. And then it's going to continue on.
Okay. Interesting. So it looks like this staircase that we walk up
Yeah,
forever.
it bounces up.
Okay. What is the domain of ceiling?
Well, you can put any number in. You'll get something out. Any real number.
Right. You can put any real number into this. What's the range?
Well, all integers.
Integers. Yeah. All the integers. So you cannot get 1/2 out of ceiling. Or you cannot get the square root of 2 out of ceiling.
Because ceiling, by definition, always is an integer.
Yeah, always an integer. Now, you earlier today used the phrase real integers.
But all integers are real.
Yeah, all integers are real, but there are some interesting integers in complex, like I, or 1 plus I. Anytime the integer part of the I is an integer, like 1 plus 2i, 1 plus 3i, 1 minus I, that's called a Gaussian integer. So there are non-real integers, and they're named after Gauss. Pretty cool, right?
Yeah.
So Gauss didn't just sum up 1 to 100, he did some other stuff.
Yeah.
And got some special integers named after him. Anyway, cool. Hey, good job. Graphing ceiling. Pretty interesting functions, floor and ceiling. Pretty interesting.